Welcome to Intel on AI, the podcast that connects leaders with listeners. My name is Heather McGuigan, and I am your host. Today's guest is Matthew Formica. Matthew Formica is a seasoned technology executive and business strategist with over 16 years at Intel Corporation, where he currently serves as Senior Director and Head of Edge Product Marketing and AI PC Edge AI Software Developer Relations. In this role, he leads a global team driving go-to-market strategies and programs for Intel's multi-billion-dollar edge computing business and AI inferencing developer relations across AI, PC, and edge platforms. Matthew, welcome to Intel on AI.
Thank you, Heather. Great to be with you.
Now, I have to ask you first, your job title, I'm going to say it again. So, Senior Director and Head of Edge Product Marketing and AI PC Edge AI Software Developer Relations. Do you have to say that every time?
I don't. Usually it's two separate roles combined into one. And as we get into the conversation, we'll explain why. Usually one part of the job is kind of more front and center in any given discussion than the other.
Great.
So sometimes I just mention one half or the other half.
Amazing, because I thought, man, does he have to write that out every time? That's a lot. That's a lot to work on. Okay, can you give us a big picture view? What does Intel's edge business look like today, and why is it such a critical focus for the company?
Yeah, sure. So Intel has been in the edge for over 45 years. It's been an important part of the company. And today the edge business spans many different industry verticals: manufacturing, healthcare, retail, and many more, smart cities, etc. Over 300 separate, distinct device categories that we represent in this business. And that amount of scale, over 200 million processors sold into the edge over the last 10 years from Intel, over 100,000 deployments that we've done, represents both a very large existing business and a lot of opportunity for the company. The edge is growing fast. We're a part of Intel's broader PC and client business. That business, while far larger than our edge business, is not growing as fast. And so this represents an opportunity for Intel in all of these markets to continue and accelerate its growth.
So, you've said the market often overlooks the scale of Intel Edge's business. Why do you think that is? And what's the story that needs to be better told?
Yeah, I think part of it is that at times it's not a sexy part of the business. It's a part you don't see very much. You're used to thinking about Intel in, the desktop or laptop you might be using, but you don't always think about the fact that the cash register that you're checking out at has an Intel processor inside, or the X-ray machine at your local hospital is running on an Intel processor, or the robotics that are driving, manufacturing are running Intel processors. So you don't see them. And so they're out of sight, out of mind. They're just how the world works around you. But in fact, they're critical for Intel. And when you get into it, you start realizing that some of the things we value most in the world are actually made possible because of edge computing driven by Intel. So the ability to get product around the world in a smooth logistics way without damaging that product along the way and in warehouses around the world relies on a lot of edge technology. The ability to have smooth flowing traffic through a city relies on traffic management systems and a lot of edge technology, and many more. These are all areas where Intel plays a significant role, and our lives would not be nearly as effective as they are without all of those things happening.
I will make sure to thank the next sexy cash machine that I pass by and say, hey, thanks, cash machine. Thanks,
Yes,
edge computing.
indeed.
Let's talk about edge. So, how would you explain its real world value to someone outside of the tech bubble, say a retail CEO or a logistics VP?
Yeah. So the edge grew up as a way of simply getting computing into all of those devices so they could start to become smart. And then the next real wave was connecting them to the Internet of Things, or IoT, as we called it. And we started calling it the edge. We realized that it was the edge of the network, this connectivity spectrum from the cloud to the device to the edge. And when you think about it that way, you realize that the more all of these things are interconnected, the more data is flowing between them all, the more businesses can get insights that help them make good decisions. And the more computing actually happens at the edge, the more real time information can actually improve the quality of outcomes. And we can build AI into those solutions to bring insights that would not have otherwise been possible and create advances. For example, um, today, frictionless retail or the ability to do checkout in a retail store without a person checking you out is all powered by edge AI. Those machines are actually very sophisticated in their ability to recognize what you're trying to buy and automatically check you out. Similarly, um, today factories leverage edge AI technology quite extensively for defect detection on assembly lines. Like the ability of humans to study every item as it comes off and find what's wrong with it, the success rate on that is quite low. But if you can point a camera and have a video stream with AI processing it, it can actually read many, many objects per second coming off the assembly line and instantly detect whether some of them have a defect or a problem and need to be taken off and not actually shipped. And so those sorts of improvements are the innovation and advantages that edge computing and edge AI specifically are driving.
You've worked across developer relations, product marketing, corporate strategy. How does the blend of your experience help when navigating such a dynamic AI environment?
It actually is critical for what I do. What I find is that the ability to first talk to the technologists and the developers about where the cutting edge of innovation is, then makes me more able to have a better conversation with business decision makers who are trying to decide what to implement into their solution. And then at Intel, in my product marketing role, I need to be able to communicate clearly that value, and so the variety of my background and experiences really helps me integrate all of those things. One of the things that I realize in doing that, though, is that there are so many different perspectives on where it's all going. No one has the monopoly on that. And we're all learning together at the pace of innovation of AI. And so the more people I can talk to in different domains, the more I learn about where it's all going.
How is Intel pushing the robotics space forward at the edge?
Robotics is an interesting, specific industry or device set of categories within the overall edge space. There are actually three major kinds of robots, or three basic categories you can think of. One basic category is industrial robots. They're typically fixed function. They often look like an arm that's doing something. You can think about in a automotive factory, they're picking up car doors and placing them on cars. And they do that very repetitive motion very precisely. The second category of robots are AMRs, autonomous mobile robots. Those look like um, little robots that are scurrying around a factory or potentially a hospital or other place, moving boxes or packages from point A to point B. They often help relieve all of our backs because they can lift heavy things that are too heavy for us to lift. Um, and they need AI to be able to navigate in that because they're in motion. And the third category of robot, the one that's actually probably the most nascent, but maybe the most exciting, is the newest category called humanoid robots, robots that look something resembling a person. And these have to be able to fully navigate around in a world that's designed for humans. They have to be able to be dexterous enough to pick things up. They need to be able to go up and down steps. They need to be able to navigate an environment and not bump into things, and even interact with people in different ways and respond to various stimuli. And so they're the most complex, but they point the way to where the industry is going. And all of these areas are getting lots of innovation and investment. Intel has a role with partners in all three of these categories. And so it's a very exciting place that we're doubling down on our investment in.
So, you've mentioned robotics as a key theme in Intel's Edge AI strategy. What kinds of robot applications are you seeing gain traction today with your technology?
Yeah. So if you think about how robots are designed and architected, there's traditionally sort of two halves of a robot. One half is the real-time controls portion. This is the part of the robot that needs to respond to actual movement instructions. It's got to control pistons and joints. It's got to move metal. It's got to decide to actually locomote the robot to do something. And it requires very precise timing. And Intel has been at the forefront of developing time coordinated computing technology that enables a robot to very precisely do exactly what you tell it to when you want it to, no ifs, ands, or buts. This is necessary for safety in many robotics environments. And so that's real-time controls. The other half of the robot is the vision and AI perception part, the ability to see and understand the environment, figure out where to go and what to do in that environment. And traditionally, those two halves of the robot were handled often by different processors, sometimes from different companies with different software stacks to control them. So there's a lot of complexity in the robot design to get those two halves to talk to each other and work smoothly. And one of the things that is most exciting about where Intel is going is across these three domains of robots, you're seeing the latest processors from Intel be able to both have the real-time controls capability and have enough AI processing to do the vision and AI perception half all in one processor. And so it makes it much simpler for a robot designer to build one part that has a lower total cost and less complexity in the robot design. So they can get their robot to market faster and more cost effectively than they could before. And so that's opening up new domains for thinking about what is the right cost of a robot of a given type. And the costs are coming down as people start to think that through. And so that will enable, I think, a new wave of innovation of different types of robots and what they can do in our world, because suddenly things that were not affordable to do before become cost effective to think about realistically doing it.
And I want to ask you about how you support this, what seems like just such a monumental task and process to undertake. So, how is Intel supporting developers and businesses building robotic solutions, especially when it comes to AI performance, power efficiency, and real time decision making at the edge?
Yeah, we are thinking a lot about this. Intel has a long history of supporting developers, both at the edge and in all parts of our business. We do this with an open ecosystem approach using open source software so that any developer can see our code and help improve it, even if they want. And so in the robotics space, we've been assembling a variety of SDKs, libraries, sample code, and more into what we're calling a robotics AI suite. And that's in preview over the next few months. It will be launching later this fall officially. And our robotics AI suite collects the capabilities all together in one place on GitHub for developers to both do real-time controls and the AI and perception half of robotics, all in one software development kit. And all leveraging OpenVINO under the hood, which is the AI inferencing based software library that runs AI inferencing on core processors from Intel.
Now, you dropped OpenVINO there. I'm going to ask a question about it. It has become a core part of Intel's AI software story. What's been the most surprising or impactful use case you've seen from a developer community using it?
There's so many. OpenVINO has been around since 2018. We have over 300,000 developers who now use it. And
Mhm.
so there's a lot of different use cases. I think some of the ones that I am most gratified by are some of the ones in healthcare. If you think about X-ray machines powered by Intel processors, they typically use OpenVINO to help accelerate the analysis of the X-ray, and at times even help get the patient more quickly aligned exactly where they need to be in the X-ray machine so that the image can get taken. And in certain emergency room sorts of situations, that time is critical to reduce as much as possible to get the best patient outcomes. And so there's real patient health impacts for being able to do that analysis as fast as possible. And what OpenVINO does is it compresses down the AI, makes it run faster on Intel processors. So whatever you're trying to do in AI inferencing, it can do it faster with OpenVINO. And so that's one example, but there are many across many different industries. One of the latest areas that it's been evolved to support is generative AI and agentic AI, which is now coming to the edge in a big way. So the technology in the field continues to evolve rapidly.
We've had a couple of guests on the platform who've been here to talk about those medical advancements. And I would agree with you. I'm always really, really curious about that sector and how things have improved. I've also been a high level athlete and also accident prone. So I've spent a lot of time in emergency rooms with a lot of x rays. And I waited for a lot of things to get it just right. So I love this concept that we're going to start to just do things more efficiently, where people are going to be able to get the best kind of care a little faster. So you launched OpenVINO Model Hub. How does that unlock for developers or enterprises looking to get into AI solutions into the real world faster?
Yeah, and our OpenVINO Model Hub is at openvino.ai/model hub, so it's easy for people to find. Um, we put there what we've found talking to a lot of companies is they don't have a good sense of what's the right model to choose and what's the right Intel hardware to run it on to get the performance that they need. And they don't want to have to try every model and buy every box with an Intel processor to figure that out. So the Model Hub helps them shortcut that. They can quickly scan popular models and they can then select from over a dozen different Intel platforms to see how those models perform on those platforms. And that helps them make a good early evaluation decision on which model and which Intel platform will do what they need it to do. We also include links on there to where they can get the optimized model, often on, say, Hugging Face. And we provide links to sample codes that if they're developers going there, they can quickly get started programming using that model that they were just looking at. So it's kind of a one-stop shop to help them get going.
I'm going to shift over to talk about AI PCs, which are a big part of Intel's future. What role does developer adoption play in that evolution? And how are you helping ISVs and devs to take advantage of what these machines can do?
Absolutely. And OpenVINO is a key technology building block and are for both AI PCs and Edge running on Intel Core processors. And we do a lot to support developer outreach. The reason for that is the promise of an AI PC is that it can use AI in compelling ways right on your device without having to wait for the cloud to give you new and compelling experiences. But who's providing those experiences? Some of them will come from operating system vendors like Microsoft with Copilot Plus for sure. But so many of them really will be driven by software developers, ISVs who are building unique and creative solutions we might not even have thought of yet. And so it's critical for us to enable as many of those ISVs as possible to be getting great AI performance on Intel processors and AI PCs so that there's a rich ecosystem of options for customers who want to actually adopt AI PCs in their workplace or at home.
From your vantage point, where are you seeing the most exciting momentum with Edge AI, specifically industries, regions, or types of applications?
There's kind of a new inflection point that I see actually happening now in the industry for Edge AI. Traditionally, um, Edge AI was really about computer vision. That's the dominant data type for AI at the edge. It's cameras looking at things like the defect detection camera on the assembly line example I mentioned earlier. That is so common at the edge. But we've seen this wave of generative AI and agentic AI coming in to the industry as well. And in the early days, those were big heavyweight models processing text. And so they couldn't respond real time fast enough to be used at the edge where you often need real time responsiveness. And they were focused on text, not on video or computer vision data. So there was a little mismatch between generative AI and edge AI that is suddenly blurring and changing right now in the industry, where there's a whole new generation of models being developed that are bringing generative AI to computer vision. These are models of the category called vision language models or vision language action models, VLMs or VLAs for short. And so they bring generative AI to computer vision so there's more context and understanding of what's happening in that video. And then there have been so many advances in compressing and optimizing, quantizing, as we call it, models for the edge with tools like OpenVINO, that now those generative AI models can actually run in a performant way at the edge in near real time, especially when running on some of the newest Core Ultra processors from Intel. And so there's this convergence of new technology around generative AI and computer vision with new processing capability in AI from Intel that is enabling a whole new set of use cases at the edge that we didn't see before. And that's part of what I'm most excited about.
So, you mentioned sort of AI meeting the physical world. What are some of the most compelling examples of that happening today that business leaders might not even realize?
Yeah. So when you start thinking about the contextual awareness that generative AI brings and the real world physical AI perception that computer vision brings, there's some really interesting use cases and that start emerging and POCs that we're doing with customers now. So one example is in the area of smart cities and emergency management. Today, um, when an emergency occurs in a city, there's a lot of different disparate databases and sources of information that might get flagged. There could be a traffic management system. There could be a gas pipeline system. There could be electricity systems. Those systems are not well integrated today. And so you end up having emergency management not knowing precisely whether they need to send fire, police, ambulance, all of the above, something else. And so then they have to swarm with everything. And you end up with a cost inefficient way, really, of providing emergency management. And so integrating generative AI with all of these services at the edge in an edge AI solution suddenly allows you to actually use your emergency management services more effectively in the city. They can have a better level of service for the whole city and do it with less cost. And so cities are particularly excited about that. So that's one example. Another example is in factories, where what we see is that there's often micro optimizations that are incrementally learned over the course of production of a product. And if you have several assembly lines or several factories, you don't really want them to have to each individually climb that learning curve to produce the most product with the least amount of defects as quickly as possible. But today, there's not really great systems in place to share those learnings from factory to factory or line to line. And so often some information gets lost and you kind of regress a bit when you bring up a new factory. And so there's the promise, again, of generative AI meeting the real world on those assembly lines to have all of the learnings from the original factory smoothly transfer to the new one. And all of that contextual awareness to just keep building from assembly line to assembly line. And so it's the opportunity to get more factory efficiency than we've had in the past.
Let's imagine that a company is AI curious, but overwhelmed by options. How would you advise a C suite team to start thinking and implementing AI practically and strategically?
I think you're describing most companies out there. Actually,
I think so. And I'm kind of obsessed with AI curious
yes.
as a term.
That everyone's in that situation right
Yeah.
now. And I find that a great first place to start is to brainstorm use cases for the organization. And often that's best done with someone who understands what the technology is capable of and where it's going to be thinking that through. And then the next step is the POC phase where you start trying some things. This is often probably the place where things get stuck the most. Um, and my recommendation is typically to start with relatively off the shelf hardware and software. Because if you build something completely new from scratch that's not connected to or integrated with the systems you already have deployed in your retail store or your factory or whatnot, then you'll get to the deployment phase and the TCO won't pencil out because you're saying that everything needs to be bought all new again and probably at 3 times the price. When in fact, and this is what we find as Intel, usually the Intel based systems you already have deployed in all of those locations have great AI capabilities and can do what you already want them to do if you start early enough thinking about using what you already have. And so integrating AI into an existing set of deployments, workloads, and use cases is the way to get the best ROI out of edge AI deployments versus assuming you need to start completely with a blank sheet of paper.
One last question for our chat today. The question that everybody asks and no one loves to answer. What's next? What gets you most excited when you look ahead at the next 12 to 18 months in edge in the AI space?
Yeah, I actually I touched on it earlier, but it is actually what gets me the most excited. So I like to keep talking about it, which is this inflection point of agentic and generative AI meeting physical AI and computer vision. I've been in this space a long time. I've seen the computer vision trend from when it was a new trend to now it's, you know, for some it's old news. But I am more excited about this inflection point than I've been in many years because I see the opportunity for real insights into the business to come that were not possible before. And we're just scratching the surface of the use cases that will emerge. And so I see AI at the edge having been, sort of, it had grown in adoption and innovation, and then it kind of flattened out for a few years. And now it's going to start going up again like this because of all this new technology that is now possible at the edge when it wasn't 2 years ago. And so that's what gets me most excited about the next 18 months.
Amazing. I want to thank you so much for coming on to the show today. You seem to really have like your finger on the pulse of what's going on. I feel like you just know. If I need to know something, I'll call you and be
All
like,
right. Well, happy to
tell me
chat
what's happening.
anytime.
I want to know
Great
what's
chatting with
going on."
you today. Thank you for having me.
For everybody listening to Intel on AI, this was Matthew Formica. My name is Heather McGuigan, and I am your host. Thank you so much for watching today. Bye.
Visit intel.com/AI to learn more.